Moving on to percentiles and quartiles. Okay, percentiles are measures of central tendency that divide a group of data into 100 parts. So just like we divided our data up in half when we found the median, we do the same thing but we continue to divide it up into 100 parts, and each of those is a percentile. So you would have the first percentile, second percentile, and so on. And the 50th percentile, right here, is the median. All right, so we'll see how to calculate the percentiles of a data set. Right, so the percentiles have no values between them. All right, so there's no such thing as the 87.5th percentile. It's just the 87th percentile or the 88th. So you want to think of them as 100 distinct parts. And they are applicable for ordinal, interval, and ratio data, but not for nominal. Okay, and so how do we organize this to calculate the percentile? You organize the data in smallest to largest, so ascending order. Calculate the percentile location index I. So the location index I will give you the location of the percentile that you're interested in looking for. So here's our formula right here. And so that's the index I, and it is equal to the percentile that you're interested in. So let's say you want the median. You would put 50 there for the 50th percentile. Divide that by 100 and multiply it by the size of your data set, n. Okay, and then this is really important. Determine the location. We have two different cases. Case one is if I, your index, is a whole number, then the percentile is the average of the value at the ith location and the value at the I plus 1 location. Or case two, if I is not a whole number, then the percentile value is located at the whole number part of I plus 1. Okay, so we'll look at some examples to see how to calculate those. So first example here is find the 30th percentile of the raw data. So we can see that that is not in order from smallest to largest, and it's really important that we do that. So let's do that first. So 5 would be the lowest, then 12, 13, 14, 17, 19, 23, and 28, right? And you can count, make sure we have all those. N in this case is equal to 8, size of our sample. And so to find the 30th percentile, we want to use our formula, I, for location index. And it's going to be P, remember, over 100, multiply that by N. And so P in this case, we want the 30th percentile. 30, divide by 100, and multiply that by 8. We end up with 2.4. Now, so that's the location I, 2.4. So the location index I is not a whole number, so you go 2.4 plus 1 equals 3.4. We want to take the whole number part of this number, so the location would be 3, and so of the ordered array. So P of 30, so the percentile, the 30th percentile, that's how we denote it, capital P subscript 30 would be 3. So this is 1, 2, 3. It would be right here, 13. All right, so see if you can try an example. Here, try to find the 75th percentile of this data set. So you need to go through the same steps that we did in the previous slide, and you can check your solution in the Chapter 3 solution slides. Okay, so I'll leave that with you and see how you do. Moving on to the quartiles. Now, the quartiles are when we divide the data up in half, we get the median, that's the 50th percentile. But then if we divide the bottom part in half again, we get what is called the lower quartile or the first quartile, and it's the 25th percentile. And also, if we divide the top half in half, we get what is called the upper quartile or third quartile, and it's the 75th percentile. So Q1 is the 25th percentile, Q2 is the median or the 50th percentile, and Q3 is equal to the 75th percentile. Okay, so they are not actual values in the data set, or they could be values in the data set, just like the median. Sometimes it's an actual value contained in the data set if the data set is odd. If the data set is even, then it's not an actual value in the data set and it needs to be calculated. Okay, so calculating the quartiles, here's an example. We have an array of 8 values, and there they are there. X, they denoted by X. So 106, 109, 114, 116, 121, 122, 125, and finally 129. Then the lower quartile, or the first quartile, Q1, we would calculate the location index I as 25 divided by 100, multiply that by 8, because in this case n equals 8, and we get 2. And we do the same thing for Q2, we get 4, Q3, we get 6, right? So Q2 is the median, keep in mind that's the median, and we put in 50 there. So we get 2, 4, and 6 for those location indices, and then we can then calculate the value. So this needs to be put into order from smallest to largest. It already is. So we can see that the 2, that it's when I is a whole number, in this case, the quartile is the average of the ith and the ith plus 1 value. So 2, it would be the average of 109 and 114, which is what they have. So the lower quartile value is 111.5. The median value, because it's an even number, is going to be, we cut the data set in half and then take the average of 116 and 121, or you can use the location index I formula to get 118.5. And finally, for the upper or third quartile, it is going to be a 6. That is a whole number, so you need to take the average of the 6th. So 1, 2, 3, 4, 5, 6. That would be 122 plus the next value above it. 122 plus 125 divided by 2 gives us 123.5. Right. Here is an example for you to try. We have an ordered array. It's already set up in order, smallest to largest, and you can then determine the Q1, lower quartile, median Q2, 50th, right? And then the Q3 is the upper or third quartile. So we have the 25th percentile, the 50th percentile, or the 75th percentile. You can think of them as either way, and see how you do. Calculate those and see and compare your answers to the solutions in the chapter 3 solution slides. Okay.